The investigation into the collapse of the Champlain Towers Condo in Surfside, Florida, investigators just gave us a major update showing what they've been up to for the past year. They have completed their testing and turned the entire warehouse worth of debris back over to the Miami-Dade Police Department. So what I'm going to do for you here is I'm going to take this big presentation and I'm going to condense it down here to just a few minutes and make it very understandable for you. And I'm going to give you the update of what they're working on, what sort of testing they've done up until now on these concrete slabs that they've built. Families of the victims had their 4-year ceremony, the remembrance ceremony this week, and they're frustrated. They don't have answers yet. It's been 4 years and they're wondering, when are we going to see something? Well, luckily they're just right around the corner if they can just be patient a little while longer. And NIST should have their final report out before the end of 2025. It was originally supposed to be done by June of 2025, but they did have some setbacks along the way. Hopefully it will be out soon, but here's what we have so far. And this right here, I think, is one of the most valuable photos that NIST has provided for us because it shows us a few things. Here is that column right here, that K13.1, where we think that it now initiated. Originally, I was back over here, a little bit outside the picture, at M11.1, probably a little over 30 feet away. That's where I was originally thinking that it happened. But once the evidence came to light here about seeing the cracks opening up here 2 weeks before the collapse, that's when I changed my mind. And then, of course, a lot of the engineers that they hired had come in and said that this is the likely location. But look at something else that you can see here. And this is what I had pointed out on one of my videos on this last year. Look at the distance between this column and all the way over here to this column. It's way too long. And that's, I think, what contributed to the sagging. I don't think they should have had that much distance. And it's the same between this one here and this one over here. But yet when you look at these back here, these are a lot shorter distance. See, these are a lot more manageable. Look at these distances between these two. Much shorter than this distance. So that's why you kind of look, you see this sagging here. And remember, there's cars underneath here as well. So initially, this pool deck right here was sitting attached to the tops of these columns right here. It was here, it was here, it was here. So this whole pool deck has actually fallen down about 6 feet. So even though it looks like this belongs on the lower level, it was really up above. You can see where the slab used to be. All of this was at this same height right here. So this is a very valuable picture here that tells us quite a bit. Okay, so NIST gave this presentation at the Structures Congress 2025, which is put on by the Structural Engineers Institute of the American Society of Civil Engineers. Now, this was done in April of 2025, and I would have had this information out to you on another video, but I was so busy at the time working on that Myanmar earthquake video, and then, of course, the Bangkok tower collapse video. And in addition to that, I also had at the same time going on the Jet Set nightclub collapse down in the Dominican Republic. So if you haven't seen any of those videos in those series, you should check those out. So they, of course, basically showed the description of the building here. And of course, it was the east part of the tower that collapsed. And right now, NIST is focusing a lot of their attention along this 0.1 line of columns on the southern end of the Champlain Towers South Condominium tower, where it meets up with the pool deck. And remember, it's the pool deck that collapsed first over the underground garage. And then 4 minutes later, the east part of the tower collapsed. NIST also gave updates on their testing that they've been doing, especially on the cement slabs and the connections here between the floor slabs and the columns. And a lot of the testing that was done last summer in 2024, a lot of it seems to be centered around here. These column slab strips here that are shown up from the floor plan, they're right along the southern edge of the building here, along this 9.1 row of columns. And so here's what they're showing, the detail of the slab, where if you look over here on the left side of it, this would be the pool deck. And then there's a step up to the lobby level right here. This is the lobby level slab. And that's where they're focusing all of their effort. And that's what they're looking at. They're looking at these beams that are stretching here from the southern end of the building. See, so here's your columns. Yeah, so these here are K, L, and M, if you look at the columns. And then if you look right here, you'll see the beams extend from the column out underneath the pool deck, as you can see here in these 3 sections. And then these two are connected horizontally, and then this one's connected horizontally. So they're examining the structure here, and that's what they're showing here, these beams type A, and how they're connecting to the building, and they're simulating it in the laboratory at the University of Washington. And if you remember, I showed you some of this early in 2024 about how the collapse started here, and it looks like it took place across these columns at the bottom, but watch the upper part of the roof right here as I advance it. So watch here, it's going to drop a little bit. See, there's a 100-inch drop right there, and then it just went down. So that's sort of what we showed last year. They presented this at the conference. Two of the things we want to keep in mind, too, is that these are the codes that they were using at the time the building was built. So they were going by the South Florida Building Code of 1979, and typically these are updated like every 3 years. So it's probably gone through at least a dozen iterations in the 40 years since then. And probably very similar, too, here with the building code requirements for reinforced concrete. So this says 318.77. That's from 1977. And it is now at 318.19. It's all the way into 2019 is when there was the latest version. And then they, of course, showed that how the penthouse was added after it got approvals and everything and permits were issued. Although it's still questionable whether this had anything really to do with the collapse. Simply because two big things here are the as-built errors and the original structural design as having errors in it as well, were the biggest, such that even if there wasn't this penthouse here, the building likely still would have collapsed, especially with all of the stuff that was added on later. This is what I think is going to be the core of what will be NIST's final root cause when they do their final report, because what you're looking at here, these are some of the factors that led to this critically low margins of safety in the pool deck, but these first two are bracketed, you see this? And so it says together, it caused the bulk of the critically low margins of safety. And it existed right here. It existed from the time construction was complete, 40 years before the partial collapse. So this failure was already in the works just because of these two here alone. And then later in 1996, when they added these heavier, more extensive planters that added more significant load on to an already bad design, and then they added more fill and more paving, and then, of course, corrosion of the slab reinforcement. So think of this as like your Swiss cheese model that they always talk about in the plane crashes. They talked about this here, which we've mentioned in the past before, how there was a lot of congestion and a lot of columns from the rebar. What they showed here was 9.75% vertical reinforcement in the column versus the 8% that's allowed. And then this is a big issue too that they've brought up, and that is, so this is the, let me show you what's going on. This part right here is the pool deck slab over the garage. And when it meets up to the southern wall of the building, here are the columns that go all the way up the building, this green, right? And then there's a step up that goes to the lobby slab. So you've seen this drawing, and I've showed you this before, even on this video. Now, here's the problem, okay? And then this is the beam under the slab that they poured as well. The problem is the column here is green, which is 6,000 PSI concrete. But then when they poured the slabs here, and you can see how the slab goes all through here, they made it 4,000 PSI. So the problem here, the error here, is in this area, this is supposed to be 6,000 PSI. So the problem is how do you get around this dilemma, this error? How do you make it so that the slabs and the column are all poured with the same concrete? Do you want to pour all of the floor with 6,000 PSI when you maybe don't need to? So here's the way I think they probably could have done it. So when they're making all of this here, they frame everything with plywood. What they could have done was along the right side of the column, frame it all in with plywood, and then on the left side, frame it all in with plywood, and then just pour all 6,000 PSI concrete here. And then you can remove the plywood, maybe put a few rods going this way like they've got, and then pour the rest over here for your slabs on either side of the column now. And you can do it pretty much once it dries and you take off this plywood. You should still be able to pour it here and have it made up without any problems. You might recall I brought this up back in 2021, not long after the collapse too, about how they added a bunch of palm trees and how they were tall trees, and they likely added a lot of unnecessary weight here to the pool deck. And it's no surprise that this is the area where the collapse initiated. Now, this is some new information that they released to us that we hadn't seen before, so I want to zoom into some of this here. Now, the reason why we hadn't seen any of this before, look at this, because of the litigation that was going on that pretty much ended a couple of years ago. It says here, tens of thousands of additional civil litigation files transferred to NIST since March 2024, used by NIST to populate a timeline of pool deck renovations. Now, this came from the CTS receiver. That is the Champlain Towers South court-appointed receiver who was in charge of dealing with anything and everything and evidence and funds and granting access to the property, like anything related to the property. The judge appointed this person, a very well-respected lawyer who took care of all of this and worked with all of the attorneys to come up with that massive $1.1 billion settlement, saving everybody years of trial time. So when we look at this and zoom in to what was saying, I did find something interesting here. Water that was being caught between two slabs somewhere. So a 3-inch hole, build a gutter around the hole and pipe to drain. So it says here, need to core 2 inches hole to release water that's caught between the sandwich slab. So I would really like to know where this was from. And then here's another interesting one here too. It says the electrical box outside the elevator lobby needs patched, I guess, to stop water from coming out. So that was kind of interesting. I don't know what kind of problem they would have had there that they needed to go in and patch this thing. And then when you look at the floor plan, so it looks like this was done back in July 12th of 1996. This is around the time they were rebuilding the pool deck, because here you can see it says cool deck. And cool deck is that white kind of concrete that doesn't burn your feet when you walk on it in the summer. Pavers was the worst thing they could have added. They look beautiful, but man, they are not kind to your feet on the hot summer days, let me tell you. But look at this. You got leak central. You got 3 leaks pointing right over to here. So they already had leaks basically 15 years after the condo was built here. And it looks like they had leaks over here. They had leaks over here. Basically, anywhere there was planters, there was leaks. And it's no surprise, folks, that these leaks right here are where this is column K, and that where the collapse initiated right here, and then column L, and they're both right around. This right here is that planter that I had said back in 2021 is where I think that the collapse initiated for the pool deck. Even though it turns out later on, we think that now it happened over here based on new evidence from the Miami Herald, which I'll show you momentarily. And so we think that it happened over here about 30 or so feet away. But you can see it was already leak central, and they had problems with leaks right here at the pool. So it had been leaking inside the garage. And I still don't think that this caused any problem for us because they had repaired all of that. So you can see right here, back in May of 2009, pool identified as leaking 2 inches of water weekly. So they were losing a lot of water out of that pool every week. And the water was seeping into the garage and pool equipment room. And let's see, they repaired loose tiles on the spa, nothing big there. However, they did see that the pool condition was worsening, with spalling and exposed rebar observed. Now, it's not specific about where they found it, but I believe that was what they had found originally inside the pool maintenance room down below in the garage, where there was spalling all over the place. And again, that didn't cause a leak because, as everybody knows, once the building collapsed, there was still water in the pool. It was fine. The pool looked like it was open. Look at this, man. Look at this picture. I'm open for business, folks. It's business as usual. Hours after the collapse, the pool was like, shoot, I didn't know there was a collapse. So no water left that pool. So I think based on the evidence after the collapse, we can say that the pool had nothing to do with it at all. But at the beginning, a lot of people were blaming the pool. And now here's an interesting one here too. See, in 2009, painting of the garage underway. They built a bridge over the parking garage, whatever, began painting all these columns and everything. It looks to me, and there was some concrete repair work done in the garage. That might be the repair work that was identified by Morabito in his 2018 report, where he said, you know what? Those repairs don't look like they were done correctly at all. And so that's why they continued to have leaks. And then here's some more damning evidence right here. The planters and drains, several drains blocked in the pool area. Drain lines replaced with new 2-inch diameter PVC pipes. I don't know if that means they increased the diameter or not, but the planter drains identified as full of tree roots, sand, and dirt. So now the Frank Morabito Engineering Company, he's a fairly smart guy. He had come up with a plan here to deal with this. And what he wanted to do with these planters was to replace everything there, remove those drains, put new drains in, and he wanted to make sure that they didn't put any more soil and big heavy trees in these planters. Here's what he was proposing. So what he did was pretty cool. So all of these planters, you can see there's a different hatch pattern shown here. He's adding all new material to these that are going to make them a lot lighter so they won't present such a load. And remember that K13.1, see here's the line right here for 13.1. So K13.1, that column was right here, and this planter is where they're probably going to say is where the collapse initiated from. But if you look down here at note number 7, look what he's saying. It says here, new soil and planting material shall be lightweight, 80 PCF max, and it shall not exceed 1 foot 6 inches deep except at tree locations. So the contractor shall provide geofoam infill as required to achieve topsoil elevations in the planters. So what this means is that he only wants a little bit of soil in these planters, and the bottom of it has to be that geofoam, which weighs pretty much nothing. So that was his very specific engineering change. And remember here, all of this was done here in April 26, 2021. So this was almost 60 days before the collapse. And it's like my heart just breaks that, man, if they had started this just a few months earlier, they might have been able to save the building, because once they uncovered everything here and took some of that load off, that might have helped. And then they would have definitely seen probably the damage that was going to happen here around around K13.1 column. And they could have put up shoring poles, which is what I'm sure they probably would have done anyway, all around the strategic points. And so look at his improved plan. He was going to add a lot more drains all the way around the deck here. And even the little planters that were added later are going to have drains. I don't think those little planters had drains at the time of the collapse, but look, he's going to be adding drains all over the place. And here you can see definite sloping towards the center of the drains, wherever there's a drain location. See that? So he wants grading going down to the drain, which I don't think was there before. It was pretty much flat. And compare this to the original floor plan, and you can see there was only a few drains here. There wasn't really a whole lot. And they are showing that it sloped, but yet somehow it didn't appear that it was sloped, because that pool deck was collecting a lot of water after it rained, as I had showed you in the past. Now, one thing to remember is all of this was a parking garage underneath all of this rubble, even including here under the pool deck. So there was cars parked right up against this wall. Now, early on in the investigation, many people hypothesized that somehow the pool deck had come separated here from this wall. So this is a wall that separates the property from this walkway here that leads to the beach, and it divides it away from 87 Park Ave next door. And so the reason why they're saying that this separated from the wall, the plaintiffs that were suing the developers of 87 Park right here were claiming that when they were pounding in the sheet piles, when they were building this building, that the noise and vibration from it was being felt by the neighbors here in Champlain Towers. And they're claiming that it exceeded the allowable noise and vibration limits. And they feel that that's what led to the eventual collapse of the building. Now, a lot of experts had focused on that at the beginning. I don't think that's where it initiated. And you're starting to see them, including, I think NIST is going to come out and say that it happened right here at this column. So that's where the punching shear initiated. If 87 Park decided to fight it in court, they would likely had a chance of winning, except the plaintiffs here, if they show up in court with all of this data that says these guys exceeded the noise rating, then they have an argument that could possibly sway a jury. Luckily, the insurance companies for all the contractors at 87 Park settled out of court. And here's another angle of it right here. So you can see how it slopes downward. So they still have to investigate the failure initiating here, and there's 6 possible ways of failure here that they have to look at here, and they got to rule them all out. And so it turns out here that the last one there, that B6, the slab unseating, so they chose B6 at the bottom right because the slab being unseated by being pulled off of the wall towards the north makes the most sense. And they made this decision based on the evidence at the scene there and the scrapes along the top of the wall and the damage on the rebar. So this means the separation of the pool deck from that south wall did not initiate there, but rather it initiated somewhere north of that south wall. at the column K13.1, indicated with the parking space 75 on it. So then they spent an enormous amount of time, too, testing the columns. So here's a column right here that they had to build, and they duplicated exactly those column ties, the way these reinforcement bars were tied up. And so they put it on this big infrastructure here, and this is a big compression machine that provides this sustained load so they can test these lap splices here in the concrete, and they just squeeze it together until the column shatters, and then they use that information here to determine how strong these columns were and whether they were up to snuff or up to the original design. And they did the same thing over here with the lobby and pool deck. So here, as I've showed you before, is that pool deck right here, and then it steps up here to the column and then becomes the floor for the lobby. So that's the lobby level slab. And then beneath it is that beam A that I've showed you numerous times. So then at the University of Washington, they were duplicating the pool slab that you see on the right there. And they have all of this hydraulics connected here. And what they're going to do is set this whole thing up with a bunch of hydraulic load presses that you can see it's slowly putting stress onto the concrete that they made to see how well it holds up. So there's one of those load presses there. And there's a column in the center of this slab there. So the girl's pretty much almost on top of it. It's a little bit over to her left. And so they're going around and they're checking where all of the cracks start appearing, and they're going to trace them. So you can see, and the column, I assume, is going to be right in the middle where that, you can sort of see a marked rectangle in the center of the screen there. And so they just keep pushing the load down until it starts to poke through and they get a punching shear at the end. Now, in these tests, they also used corroded rebar to determine how well this concrete pool slab would have held up during this punching shear. Now, one thing I wanted to point out here to you, I'm looking at all of these lines here. See these grid lines? I don't think that these are random grid lines. I am theorizing that what they did here was they duplicated the spacing of the rebar rods. And so this would be the column in the center. And so it does appear that there's either 2 or 3 rebar rods that would have gone across the connection there on the top, and same with the bottom. Because remember, they want to try to duplicate it, including the errors of the as-built condition of the building. So these should match the spacing where I talked about earlier on the floor plan that it looks like the builder did not match the spacing that was called out for on the floor plan, and specifically where the floor plan called out that you were supposed to have 4 rebars going across both in the horizontal direction and in the vertical direction here going across this column. And so they did all sorts of testing on different slabs that they made up, and they were coming up with their critical shear crack theories here to determine where the weaknesses were. And they also did slab column connection tests. So here you can see where you had a shearing right around a column. And let's try to determine all of our metrics here of what was controlling that and how things failed, and determine where and how they failed. And then over here, same thing. And they even duplicated the spacing that they saw in the as-built to see how well it would have done around the column, and why this design was so complex for them to really get a hand around, like, what's really going on here. And it all happened around the 111 stack, as we call it. So all of the units that are 111, 211, 311, all the way up, this is where it happened. And Sarah Nur's apartment right here, which I've showed you many times before on the slides, and she had the blue patio furniture outside. This is where it was all taking place here, right in front of those planters. Unit 111's patio drops down 7 inches from that to make her patio slab that she had there. And then from her patio slab, that then drops down another 11 inches down to the pool deck. So that's why when you look at these, you see these huge 18-inch drop here from the lobby level down to the pool deck level. And then, of course, see there's a beam A that goes this way, a beam A that goes this way, and then they're connected together here right under the patio slabs for additional support. And so here's that massive testing facility here that they built. Look at all of this text fixture here compared to what looks like, I believe it's a 12-foot tall ladder. So this is no small structure, and it took them months and months of work and calculations to, like, of course, to construct and cure this concrete, this massive concrete slab here, and to double check all of their numbers over and over again here to make sure that this test was going to be done correctly. And so what they did here was they were doing these joint damage tests, and so they would pull apart. This is that connection here we were talking about. This on the right is the pool slab, and then this is the step up, and then over here on the left is the lobby slab, and then in the background you can see the column connection there. So here you can see the hooked number 5 bars in the lower slab broke out of the beam during the test. So now they can analyze how things are going to look, how they should look. And then here's the column bars at the south face. You can see they lose their cover and they started to buckle. See, so here it is coming out, and you can see right here, it's slightly bent there. So it is buckling. And then here, they're looking at the column bars at the north face. They lose their cover and they start to buckle as well, too, once the slab gets pulled away from here. So you can see not having all of that beam here puts a lot of undue stress on these columns. And these were the ones like the K and the L and the M that are all along that south wall of the Champlain Towers Condominium tower building. Now, they also did these structural tests last August in 2024, and I just basically showed you a quick frame of this in an update last September, but didn't really show you everything they were doing. So what they were doing was evaluating these lap splices that they didn't like. They thought they were too short. I think these vertical rebars coming down the column should have gone all the way down into the foundation here, but they didn't. These dowels that are coming up from the foundation come up, but to have just that little overlap, I don't think that looks like it's enough. So that's what they were testing here. And sure enough, you can look at the sensors here and see how they put more sensors down near the bottom here to test the strength of it, to see how this column should have acted. And here it is here. You can see it looks like they did about an 8-foot tall section here, a recreation, because this, I believe, is an 8-foot ladder. And then the results of the short lap splice testing they showed here on this replica column, you can see how it shattered after the load testing. And then there's the exposed rebar in the middle. On the right photo here is a specimen that had no lap splices. And what happened to that one? Now, everybody has always been asking me, well, what sort of testing that they did on the slabs and columns that were pulled out? Well, they took hundreds and hundreds of samples. So looks like here, 594 tests completed for mechanical properties of the concrete. So they will take a core sample like this one. They'll put it right here into the machine, and they'll test it under compression and see when it fails. And they'll also, it looks like they've got it set up so they can stretch it as well, put it in tension, so they can test, as they're saying here, the modulus of elasticity. So what they do is they stretch the concrete and then let it go again and see how well it returns back to its original shape. That's the modulus of elasticity of any material, really. And so then they took another core here. You can see they've got it on its side, and they just put pressure on it until it splits, and they want to see how it splits. And of course, they did 183 tests for mechanical properties of reinforcing steels. I showed you some of this back in September of 2024. Okay, now here is where in their materials and testing evaluation, they want to study the degradation mechanisms. So if you look at this diagram on the left, so what happens on slab column connections like this, and this is over the pool. So here's the pavers, there's the sand under it, there's a waterproofing membrane, and then the topping slab and everything else, and then the floor slab. And what happens over time as water got in, you can see these squiggly black lines are the cracks that developed that had to be fixed because H2O was getting in, chlorine is getting in, oxygen, carbon dioxide was getting in. All of these, once the moisture gets down in there, see that this becomes like a highway directly to the rebar. These cracks provide a direct path of moisture right to the rebar. All of that can change the pH of the concrete and lower the strength of it. And once the rebar gets rusty, it expands and cracks the concrete even further. And that's when you get spalling and you get chunks of concrete that fall all over the place. So those of you who saw my video of the Fort Lauderdale Marriott Harbor Beach, that I uploaded back in August of 2021, you saw how in the garage I showed you it's all fresh. This just fell from up above. Look at all of this massive amount of spalling that's going on right under this drain line right up here. You see this? Numerous examples of spalling on the ceiling, and how I was already finding chunks of concrete right there on the floor, as you see here in these videos. I mean, that was just pretty unnerving. I've showed you this in the past also too, where they went around and looked and they did structural checks at many of these column locations and found that in some cases there was too much slab flexure here. As I had showed you, I thought that the spacing between the columns here all the way down to here was too much. So you were getting too much flexing right along this row of columns here. And then some areas under the building, it was a little bit critical as well. Okay, so now they've taken all of this information that they've gotten from all of the testing that they've done, and they're feeding it into the software that they have. This is very powerful software. They can remove layers. They can remove the outside, the concrete, and look all the way into just the skeleton of all of the columns, and they could slowly add back layers and test everything. They could test this building 6 different ways to Sunday. We've mentioned this before, but they showed how the rebars were embedded on average 2 inches into the material, into the concrete, when they should have been right here, 3/4 of an inch. That's how the design calls for it. So the more you embed it in to the center here, the lower its ability to handle the loads. And they, of course, they brought up the points. You see how here on the floor plan, on the left, this snippet from the floor plan, they show 16 number 5 rods going horizontally and 16 number 5 rods going vertically. And what that really should have meant with the spacing is that you should have had 4 rebar rods going across the column connection, but yet in all of the columns, they only found 2 rebar rods that were going across the column connection. So that's what they're showing in this picture. And then over here, where you had an actual punching shear, the slab top reinforcement spacing here, you can see because it was spaced out too far, in some cases, they were 20 to 40% wider than required by the drawings even. And so that's why you ended up with only 2 rebar rods over the center of a column. And again, they reiterated the point that we've talked about before, where they had 9 inches of sand in the setting bed out on the pool deck for the pavers. And I still can't figure out why it would have been 9 inches anywhere. And I would really like to know what spot that this was found at. Because here in Florida, when we do paver bricks, we do it over 2 inches of sand. There's no need for 9 inches of sand. Like you see here at my house when I was having my paver brick driveway installed a couple of years ago. Unless something was really wrong or out of whack and they were trying to use it to level the spacing, you know, to act like a filler, a gap filler. See, because this is normally what you have here. You have your 1 1/4 inch paver here, and then your sand would be right here, a couple of inches at the most. Then your waterproofing layer. And then, but this is what they found too. They did it over the old tile and the old mortar. So you have another 1 3/8 inches there. And then, of course, the 2 1/8 inch concrete topping that was on top of the original slab. So it's like, this is like going to McDonald's and getting one of those massive Baconator double-decker type things, you know? And this is just unbelievable how much weight that this would have added on there. Not only that, as I've showed you before with some of my previous diagrams from like weeks after the collapse, when you have rain like this, and you can see that there was some rain down here at the bottom of this picture, all of that rainwater fills up and saturates this sand. So now you have 9 inches thick of rainwater. What do we know about water weight, folks? Well, we know that water weighs 8.3 pounds per gallon. So you multiply that by all of the gallons of water that are saturating in that 9-inch sand, and you have a massive amount of weight that was never even considered by the original engineer. And of course, another thing they pointed out here out on the pool deck was the corrosion of the hooked column reinforcement bar. So this is the column where parking space number 28 was. There it is. So what you're seeing here, this was down on the garage level. All of this right here is the garage floor. And so the ceiling slab for the garage would have gone right here. This is the pool deck slab. And when it did the punching shear and it came down, and you could see it's all the way down here on the bottom now with all the debris on top of it, it left these rusty rebar rods here that were hooked. See them? And here's close-up shots of it in the warehouse, where now you see how it's all corroded, and it should never have been like that. So that means that somehow water had gotten to some of these connections over the years. Water, moisture, chlorine, you name it. Now, this is what still bothers me about many engineers today. When they're confronted with cracks, they seem to brush it off like nothing's wrong. Now, if you saw my FIU bridge collapse video that I uploaded earlier in 2024, you remember I talked about this, where the engineer there, the engineer of record, was presented in a meeting how the cracks kept getting bigger and bigger. And now people could stick their fingers in there, and he still didn't have a problem with it. And being a professional engineer, a licensed engineer, that guy from FIG Bridge Engineering should have known, because the AASHTO rules for concrete on bridges, if you have any crack over 1/16 of an inch, you have a problem and you need to address it. I think too many engineers see a hairline crack and it doesn't concern them when it should be, because everything starts out as a hairline crack. Then it gets bigger. And then it gets bigger. And supposedly the manager of the property there had told Morabito engineers they had, I believe, somebody from their staff there, I don't know if it was like interns or what, that was around doing other types of inspections there that day. They looked at it and they weren't concerned. So here's a diagram of what it was looking like. So you had this big crack going down the wall here and an even bigger crack here in the corner. And what should have bothered them but didn't seem to bother them, they know that this cracked planter wall is sitting on top of a pool deck slab. And so if you see a crack like that running down the length of that wall, that means you have sagging. See, sagging of the slab, as the diagram shows here. And this type of sagging had to have been large enough to create these large cracks. They were just simply ignored. So you see, this should have sent up a big, giant red flag. They should have known that there was sagging going on and that something was imminent here. Okay, now one thing you should check out is this video over here on the FIU bridge collapse that I did last year. Excellent in-depth engineering video. Check this video out over here. It's my latest video on the Ocean Gate Titan submarine implosion, where Stockton Rush's wife, Wendy, may have heard the audio of the implosion. So thanks for joining us, and we'll see you on the next video.